Thank you so much. I've been kindly asked by one of you to make this presentation in English, so I hope you are kind of confident with your security, with your language skills. So far, I will not have too much trouble, hopefully, doing it in English. And this lecture will be about Java code related security controls. It will be about the security managers. It will be about writing your own policy files. Question to you. Please raise your hand up if you have ever written your own policy file. Please raise your hand up, and I will try one person, second, less than 10, I'd say. And the truth is, what I will going to show you today, it's not a common security control, because most probably of several reasons. Well, first of all, not many of us know how to implement it correctly. This is probably the very first reason, so as we do not do it anyway. And the other thing, and I'm jumping here to the conclusions. Actually, this should stay on the last slide, but it's a question whether you should do it or should use it or not. And I say it depends. And this "it depends," we have heard it many times today already. On every single speech, we have heard as the answer, "it depends." And this talk will not be much different. It depends because this security control can be a double-edged sword. You can kind of improve the consistency of your application with it, but you can kind of impact availability in a very, very negative way. So this is something one should really enjoy with care. A few words about me. I work for Capgemini in Wrocław, Poznań, and over there we do lots and lots of custom software development, many projects. And I do like to work with smart people, so if you are willing to join us, please do. I do work, or I live two lives. I live a life of a software developer, and I do like to code myself, and I'm doing it, actually working as a software architect right now, but I'm also living a second life as a security expert. It's not the best description, maybe security engineer or security consultant would be a bit better, but I try to kind of communicate the world of security with the world of development and try to influence both sides with what I'm doing. I'm the father of two. I'm an OWASP member. If you know what OWASP is, I do like to teach kids programming, and I think that's it about who I am. I usually tell people that security should be fun. And if it is not fun, and in many cases it's not fun, it is because people are doing something wrong. I'd like to start with showing you actually this piece of code. Consider it for a while. It's fun, it's funny, and maybe silly as well. You will see there in the line number 3, it's a definition of an HTTP endpoint. So in the line number 3 is something you would rather not expect from the production code. I mean, you see the system exit 0. Or you don't, because it's too small. There is a system exit 0. And now assume that you take this piece of code, that you compile it, that you build a WAR file out of it, and that you take the WAR file and deploy it on your Tomcat instance. What will be the outcome if you call this REST endpoint with this system exit 0 inside of it? Will it be 1, nothing? This is obviously wrong, but if you do not know any better, you can still raise your hand if you think it's nothing, and I will feel better this way. Is it 2? Some kind of exception will be thrown? Or 3? The application you have deployed will be terminated? Or is it 4? The Tomcat will terminate with all applications running on it. Please raise your hand if you think it's number 1. Anyone? No one? Okay. Number 2, some kind of exception will be thrown. Someone? Anyone? 1, 2? Okay, not so many. Application will be terminated. Number 3. Oh, many. maybe a half. So, point 4 is obviously the rest. Okay. Actually, I would personally expect that the application will terminate, so this is something I would say as well, that point number 3 will be true. And actually, what will happen is number 4. Tomcat will close with all applications running on it. And if you take some time to think about it, this is actually bad. I mean, a single line of code like this system exit 0 can disrupt the system. It's probably not the most evil thing that can happen. I can imagine more evil things, but actually this is pretty bad. And in fact, as I have run this experiment myself, then I have looked into the logs of Tomcat, which has kind of closed completely, and tried to examine, based on the logs, if I were able to tell what did really happen. And honestly, I consider myself to be smart. Well, we all do. But I wouldn't, honestly. Not even the request that caused the machine to terminate has been logged into the files. Why? Because the machine terminated so quickly that it couldn't. So you will have zero information about what caused the whole disruption of the system. So in fact, what we have here, and what I'm showing you, is that you can kill the applications with a single line of code. Well, we did knew it before, but it's kind of now easy to see how it can be done. And if you say that things like this will never happen to you, because first of all, you do not write such code yourself, then I will trust you. You don't. You can kind of expect from you not to do things like this. But then you will need to admit that no one from your team will do things like this. And you will not be so convinced that it will never be the case at this moment. But let's say if you have a review process, then it's all fine. You will kind of look over the code and no one will be able to do stuff like this. But then you will also need to admit that it's not only about your code. It's also about the code written by others and the code that you have put into your application as a dependency. And there will be 10, 100 more lines of code you kind of put as a dependency than the code you write yourself. Just look over the binaries, how big they are. They are huge, and you can kind of generate an empty Spring Boot project with 100 dependencies. It's just easy. And this is when things kind of start to get a bit complicated, because we are kind of, not every company has some kind of security controls to review libraries from others. Some actually do, but not everyone. And then to make the thing completely hopeless, it's also about remote code execution vulnerabilities in your application. Because if you have one, then anyone can execute, well, some kind of code, and then system exit 0 wouldn't be actually such a bad thing that can happen to your application. It can be worse. If you think that the remote code execution vulnerabilities are not so common, then I will show you some more pictures. Please consider the right side of the graph. This 24, you can see this is about struts. It's actually struts 1 and struts 2 combined, but when you see 24, it's kind of corresponds to the flows of remote code execution vulnerabilities. If you thought struts 2 is about some MVC framework, then it actually isn't. Struts 2 is about remote code execution on your servers running struts 2. And if you think that the exploitation is kind of hard, then in most cases it isn't. Well, the idea how to attack can be hard, and it has been kind of written down in this piece of code. Well, someone kind of automated the whole attack on applications using struts 2 and made it so simple, like running a script. Then you need to input the URL, and then you need to input the code you would like to execute, and that's it. So things you are kind of not really controlling as a developer. You do not want to look every day into the CVE library to see whether there was some new findings on struts or not. If you think such things do not happen in the Spring world, well, they actually also do happen, not so often. One must admit this kind of happens occasionally and is not so critical as the vulnerability you have seen before. You kind of had to fulfill some preconditions for this thing actually to run. And one precondition in this special case was that you still have the default error dialog running, and that the second precondition was that you can mirror some value you put on the outside to appear in this dialog, and by using the Spring internal expression language, you could kind of make some code really run. So it does not show the exploit, but it kind of shows the principle at this point. So things like this happen, and we must admit as developers, as architects, we kind of do not care about it. So if the vulnerability, the security flaw is found out, we might probably miss updating our software and introduce some vulnerabilities in our system. And 3 days later, we get attacked because our patching process is longer than 1 hour, and that's it. What I want to point out so far is that we are kind of missing an important security control to prevent stuff like this. Why can't we just say for the whole application that we do not want system exit 0 to be executed ever? It would be nice. Why can't we tell for the whole application that we do not want any shellcode execution? So no one is to run runtime or similar. I'll show you one more example. I do not know if you can read this well. This is about XML parsing. And I have put 3 kinds of XML parsing, 3 different libraries over here. One is DOM4J, one is JDOM, and one is JAXB. And the question I usually ask at this point is about, this is really bad code. I mean, write code like this, expose it to the public, and you will get attacked. Anyone knows what this vulnerability is about? Any ideas? XXS? Again, please. External entities. I know what you mean. You mean this one. This is actually true, yes. Yes, this is actually about number 4 on the current OWASP top 10 list. Did I mention that I am an OWASP member? There was a new edition of the list a year ago, and actually external entities, XML external entities, also called XXE, were kind of introduced on this list on a high place of rank 4. And this is how the attack looks like. I do not know if you remember that you can put this doc type element and that you can put some kind of DTD definition into the XML itself. And in this XML definition, you can kind of define your own entities. And what's fun, these entities can point, for example, to a file on your local drive. Here an example, etc password. So what will happen if someone injects such an XML into your parser? Well, it will happen that the parser will kind of try to find out what this entity is about. So it will find out, okay, this entity is a content of etc password. It will fetch the content of your file and put it into the XML, and probably then your XML validator will run over and say this XML kind of does not conform to the schema. And if you are showing, for example, stack traces to the end user, then the end user will get, well, we couldn't parse this XML, and will show the whole content of the etc password file. Bad, isn't it? Now guess what happens if instead of etc password, you use dev-random? What will happen if instead of etc password, you kind of use the same mechanism to upload files to the internet or download files from the internet? I mean, this is kind of getting bad. And it's not like we would expect that the XML parser will be able to upload or download files from the internet. It's not that we kind of would expect that it can fetch any file on our drive and include it into XML. So again, we kind of lack a security control at this point to prevent, for example, access to the local drive. I mean, if I have an application that I do not expect it to kind of have access and to read files, then why can I kind of prohibit any actions that has something with reading or writing to protect myself? Okay, this is kind of how the fixed code looks like. So you see this is a bit longer, and you have to put those one-liners to kind of turn the parsing of external entities off. But this is kind of needed for the whole mechanism to work properly. Okay, so we are actually, by showing this, I would like to get to the point and where I am kind of able to introduce this security control related to security managers, writing your own policy files, and show you the purpose, why we are doing this. And actually what I'm going to show you is a security control that is meant to protect users from developers. And this kind of sounds bad to our ears, because we do not feel as developers as if we were doing something bad. And it's not actually about developers doing something bad. It's kind of to define the perimeter of the application, what the application can do and what can't do. Because if there are some security flaws, then this might be actually the level that will protect us, that will protect our customers. So why not use it? And on the other side, we as developers are actually the most common users of code someone else has written. So this, we could kind of use it ourselves to protect us from code someone else has written. Why not? Why not use it this way? So in case someone is missing an agenda so far, right now, I will try to show you some examples how to use things like this in code, and the examples will be kind of really simplified. But I kind of expect you to see it once and to remember it. If you use it, it's another story. It depends. But I would like you to kind of remember it, and if you never decide to use this security control, then you might kind of look for others, for other security controls that do actually a similar thing, like what I will show you. Then we will speak about confused deputy problem and say what it really is, and then the time will be up, and we will try to summarize what I have shown to you. Okay. Here we go. Code security by example. I have made some recordings because online demos, it's not something that work when I do it on the stage. So I tried to kind of record the most important things to understand, and instead of typing, I will concentrate on commenting what you are going to see. So first of all, this is an editor of your choice, and I will start by typing some very simple code like system.out.println, and then we get a system property, and let's fetch a property called java.version. That's it. Let's run this code and see what it does. Well, it will output on the default output stream a value like 180.111. What it tells is actually that I am really bad at keeping my software up to date. Well, I know I'm a security expert. I know and understand that I should keep my software up to date. But on the other hand, I'm a developer, and I know that if I keep my software up to date, I'll end up with software that is working different than everyone else's. So this is the problem I have also internal. We all do have problems like this. But how would I try to act about this one? Well, I would say to myself that I'm bad at keeping things up to date, and that there is actually no real reason why this piece of software should know that I'm bad at keeping my software up to date. I would like this piece of code to restrict access to this property, to the system property, because I simply do not want it to know. So I'm in the command line right now, and I will be running it from the command line, and it's actually quite simple. What I want to point out with it, it's that we have said that this security control is meant to protect users from developers. So the means related to the protection must be kind of outside of the code, because not always the user will be dealing with the code or will have access to the code base. So the security control must be somewhere outside. And what you can see right here is that I am turning on with this flag, the Java Security Manager, the Security Manager. And I expect the default implementation of the Security Manager to prevent access to this property. Did it work? Well, actually it didn't. Why? Good question. Go into your JRE directory under lib security, and you will see many interesting files there. There will be java.security, an interesting file if you have never seen it before, but today we will kind of concentrate on java.policy. If you look into this file, you will see it kind of contains some interesting things kind of captured in grant blocks. The first grant blocks above is about the jars in the X directory of your Java runtime. Then there is a grant block that kind of is for all the Java code, not only in the X directory, everything you are kind of running. And you will see there are things like, actually, this is bad practice, and you shouldn't be doing it, and this is on by default. This is kind of how security is treated anyway. And what you see here is this permission, property permission, Java version read. This policy file is the default. If you do not define the default yourself, override with your own policy file, then simply kind of turning the security manager will make Java fetch the default out of the installation. So this is kind of something to remember. So how should we go about this? Well, just create your own policy file. And you can write an empty grant statement that will kind of consider all of the code. And in the terminal, you need to put one more parameter. Java security policy, then double equals, this is important, double equals, and then point to your policy file, make it run, and this is it. So, out of this, we will learn several things. First of all, this Java code security control I'm kind of showing you right now, this is an opt-in feature, meaning that you need to turn it on yourself. It's off by default. And probably our world would look differently if it was an opt-out feature, but it's opt-in. So if you want to use it, you need to turn it on yourself. And then you kind of need to pass a set of rules that you kind of expect that the application will follow. And if the application wants something more, then it will kind of internally throw an exception. Why? Why it will throw an exception? And the reason why it will throw an exception, if you look into, say, system get property, then you will see that there are some simple constructs like fetching the security manager and kind of checking, making the security manager check whether it is allowed to do something. And this is pretty simple. There are no annotations around it. It's a code you kind of write yourself. I mean, this mechanism is extendable, so you can define your own permissions and kind of use the built-in security features to kind of check over your code if you're allowed to do different things. So you can do even stuff like this. But actually, there is no magic involved. And you can see actually that an exception will be thrown if something is not working. What I did in between is I kind of copied the content of the exception that has been thrown, and I'm putting it right now into the grant block, and there is some syntax sugar, very simple things I need to do about it to turn it into a rule in the code. And back in a terminal, I will be kind of able to run this application again with this rule in this policy file, and you can see it works. So right now, I end up with some kind of binary, some kind of code I want to run, and end up with a policy file, which kind of says which permissions are required to run this code. And as a user, I can look over the policy file and say, okay, I agree with what you need to run. You can have it. And then I run it. And this is kind of a contract between the code and me as a user. And if someone tries to violate this kind of contract, then it will end up with such an exception being thrown. Some more examples. Let's try to do something about the file system. So let's try simply to create a file and see how it works. So we will try to create a file, test.txt, and we need to deal with this exception being thrown. Let's just propagate it, and let's try to run this piece of code. And we are running it. And this is it. I mean, the code does more than defined in a policy file. And then we kind of, again, copy out the content of the stack trace, put the content of the stack trace into the policy file, put some syntax sugar around it, and this is it. It's not JSON. This mechanism I'm showing you right now is ancient. It has been in Java forever. It's kind of used to put the whole code into a well-defined sandbox, and the code will kind of has no means, or the ideal is that it has no means to escape the sandbox. So if it did happen in 21st century, it would be probably JSON or something like this, but it's not JSON. This is kind of its own policy syntax you are looking on right now. And this is it. For the most part, only from what you have seen so far, you can gain a lot of traction. You can gain some nice things you might want to introduce in your applications. Just to summarize this, what you have seen so far, is it's so simple like turning your security manager. You can kind of override the default security manager with your own file. What we have shown here is only using the default one. And you do it by putting the flag Java Security Manager. Then you can kind of start with an empty policy file and use this policy file to overwrite the default one. And then you kind of run the run crash fix loop. So you made the software run and see what's not working. And then you kind of put the property inside and you run it again till it kind of works. And this is true for command line applications. It's a bit harder to do for web applications. I will show you how it is done for web applications afterwards. Should we use it? It depends. But I have seen projects that and their requirements where it clearly stands that the code you are writing should fulfill the principle of list privilege. And this is one of the means to kind of make the code fulfill the principle of list privilege, because the principle is very broad. People usually understand this principle actually as the definition of what the users in which roles are allowed to do in the application, and that they actually should not be able to do more than it is expected from their roles. So this is how usually people understand the principle of list privilege, but actually what it also means is that the code should not be able to do anything more than specified. So then you can kind of ask the next question, whether you are using it already, because we are still, sorry about this, still using the application servers. And this is a lot of technology, and we do not understand the half of it. And so one might ask whether it's somewhere in the application server already turned on. And the answer is most probably not. You're not using it if you are unaware of it. Because every now and then, it will cause some disruption in your system. Because this mechanism is kind of capable to stop everything. It can kind of stop any ports from being opened. So if you never run into problems like this on your production, then you're most probably not using the mechanism yourself. Okay, confused deputy. This is actually a security model that security experts are showing to us, developers, to show us that there are some security constraint problems on a very deep architectural level in our applications. And consider this one. You kind of make a REST call into your web application. And on the server side, the REST calls do have access to all the libraries, to all the functionality Java provides. So you actually make this, as a user, the call in a context of a use case. But what the code is kind of able to do, it can go over the boundaries of the use case. So the code can actually do everything. And here is an example to illustrate the problem. The man is called Jarek, and Jarek has found a very nice online compiler. And this online compiler, well, it compiles. This is the best online compiler ever. And it's better than any other compiler Jarek has ever used. The bad thing about it is this compiler uses a file, and it stores in the file all the information about what Jarek did to bill him, to make him pay for it. So the interface looks like this, that Jarek is kind of able to input his source file, and that he is also able to define the name of the output file, and he kind of receives the compile file as a result. And now the question would be, can you see here the flow, or maybe a point how to attack this type of knowledge? Why? Because Jarek wouldn't like to pay. He simply would like to use the compiler without paying. Do you have any idea? The output file, name the output file bill. This is actually the correct answer. So, Jarek can try following. He kind of names the output file. The output is to be produced bill, and he will overwrite the content of bill with his compiled file. Yay! Jarek will most probably have to pay only for one compilation, the last one. How does it look in code? I have actually prepared some piece of code. We do not go into the details because it's simple and it's boring. Just consider this. There is the main. There is this main jar that kind of triggers the functionality. This is the worker that will compile the code, and this is the billing mechanism. And this is it. And in code, when I show it to you, those will be kind of 3 jars. Confused, the main one, confused build, the billing mechanism, and work, the worker. And in txt is the input. And you will see in this input that this kind of compiler, it does not really compile. It base 64 encodes the content of the input, but I did not want to write the whole compiler myself. This is the input in .txt and the output, out.txt. And the class path definition, that's it. So the code so far is quite smart, and you will see that the build.txt file after one run has been generated, and the content is, well, base 64 encoded data. So compilation of out.txt, and the price is so high. This is what Marek has to pay afterwards. And now, you can run this mechanism several times, and it will kind of generate further rows in this billing. And this is what happens. And then we can kind of try to attack this mechanism. And the vulnerability here you will be seeing is something about path traversal. So right now, instead of writing to out.txt, I will go one up and overwrite the build.txt mechanism. And this is an attack. This is hacking, actually. This is how it works. And you can see I was able to overwrite build.txt. And right now, only the last one line is visible, and actually also the content that was compiled or base 64 encoded. Okay, we have seen the problem. Then let's now try to protect ourselves. So I have written my own policy file I am going to use, and let's see the contents of the policy file. Down here below, you will see the compiler, the worker, and the worker needs access to input and to output. This is kind of defined in these permissions. Then you will see some access right for the billing mechanism. There is something we have not spoken before, this code base and pointing out to a jar file. We have kind of defined it for the whole code base so far, but this is actually how you do it for a single jar. And look at this main jar, the jar that starts the other jars, it has to have all the permissions of others. Why? We will see why in a moment. Okay, so this is it. We have this mechanism, and right now we kind of can use this mechanism to protect our application. And what I'm showing you is how you can deal with this confused deputy problem by using the security managers and the policy files. So how you can kind of make your software more secure at this point. And you can see it works well for the standard, kind of the normal way of working. And now we will try to attack it. And bang, I mean, we were able to protect our application from the attack. And right now, you as a developer might get called in the night, and someone will say that they have spotted on their Dynatrace that some failures are happening and the code is not working well. And this is the one thing that you must not do. You must kind of not copy this content to the policy file and kind of write your own next policy rule, because if you do, then you will be kind of vulnerable again. So based on this, you must kind of be able to tell whether it was proper or improper way of dealing with this case. This is kind of the hard thing about dealing with the analysis of such things. Okay, I will show you one more thing. And this one more thing will kind of make us understand what this thing is about. See that the main jar must be a sum of all the other permissions. Why is this? Because if it isn't, it will not work. See, I mean, the worker now has access to what is needed, but the main jar does not. And as it does not, it kind of fails. This confused deputy logic you're seeing right now has all necessary permissions, but actually the runner in the main class itself does not. And this is how this mechanism works. I mean, all the code on the stack must have all the permissions. And it makes sense when you think about it, because if it was not like this, that all the code on the stack is evaluated whether it has the necessary permissions or not, then instead of attacking the file reader, you could kind of attack the confused deputy logic. So from the attacker's point of view, it would kind of change what he is attacking. So this is why the mechanism actually works this way. Okay. Let's try to summarize what we have seen so far. We have seen the security managers in action. We have seen how to write the most basic policy files. And if you ever end up writing your own, then I kind of advise that you do it for the application as whole, that you do not play with separate jars because it raises the complexity of the whole thing. Just do it for all and treat it for all. We have not seen many things like code signing. This mechanism you have seen here can be used actually to code sign the jar files and only run the jar files which are code signed by you, for example. Or we have not seen the Java authentication and authorization service integration, and we have not seen how to write your own policy files, and so on and so on. We have seen only the basics. So far, one must say that I kind of envy sometimes my mobile applications because they ask me questions. Like, these applications will need following permissions to work correctly. Do you agree to it? And we kind of, as developers, lost this opportunity for the Java world to kind of be able to show others what will be the permissions that our applications need to have in order to really function. And this is one side of the problem. The other side of the problem looks like this. It looks like the the example how this policy file can really look. This is this big. And it's not the whole policy file, it's only a template you need for a code that will be running on Tomcat. You still need to put your own rules below regarding access to the database or REST calls you need to make to other systems or access to directories. So this whole thing can be fairly complicated, and actually is. So actually, if you end up not using this mechanism at all, I advise you to think about the problem at last and to kind of look for similar things you can do. And with this whole virtualization thing, things are not that hopeless, honestly. We can do a lot with how Docker kind of isolates the systems internally. We can use other mechanisms as well. So, should you use it? It depends. That's it from my side. Thank you for the time. Do we have time for questions? I don't know. Probably not. If you have questions, then please come over. Thank you.